Hello everyone, and welcome back to the video. I'm the last one, and today I've got 3 new Sculk Sensor contraptions to showcase for you all. So, not too much has changed since Sculk Sensors were first introduced. However, one vibration was removed from them, the start eating vibration, but that's not too significant. One neat change that was made was that now you can waterlog Sculk Sensors to make them less annoying. Because now, when waterlogged, Sculk Sensors no longer make noises. And I demonstrate this new feature of Sculk Sensors in my first new contraption, the automatic item stack dropper. When I walk into the radius of the Sculk sensor, right here, it'll automatically drop out a stack of items every single time, as you'll see here. Just like that. If we go around back to check out the redstone, there's quite a bit going on here for this whole thing to function. But right here is the waterlogged Sculk sensor, which makes the activation of the item stack dropper completely silent. As for the rest of the redstone, I'll try to explain its purpose. As you can see over here, I've got an observer clock set up, with this dropper right here with items in it. When I trigger this Sculk sensor, unfortunately, I'll be getting 10 items, which is not an ideal number for an item stack dropper. In order to fix this issue, I have this comparator decay clock here, which extends the sticky piston for longer, so you can get 64 items, or more specifically, 32 items from each of these two droppers. I'm not going to be doing a tutorial per se on this design, but I will be bisecting each of its parts and explaining how they work. So, if you wanted to recreate this, you could. I'll start over here, with the wool part of the Sculk sensor. The wool occlusion prevents you from activating the Sculk sensors from too far away in your base, or wherever you decide to put it. You don't want to just be walking around and having this thing accidentally activate. It only activates when you walk over here to this specific part, which is pretty good for the design. Now, you can also waterlog the Sculk sensor to make it silent, like what I do over here. And this part here is basically the Sculk logic. It prevents you from hearing signals that you shouldn't. So like if an item falls, that won't activate this comparator. Only if you're walking will the comparator be activated. Obviously I can't walk now and show you because of the wool. The next part is nothing too special. It's just the input for the comparator decay clock. Just these 4 blocks here. Now, this next part is very important. It's the comparator decay clock. It basically is what decides that you get 64 items every single time. In order to keep this compact, I actually put a block above the first comparator that reads the Sculk. So, it's nice and compact. And I put the piston here. Now, it's important that the piston is here and nowhere else, because this is the only spot that'll get you 64 items every single time. Trust me, I've tried and I've worked around this. And finally, as far as redstone is concerned, I've got these 2 observers here for the observer clock and the 2 droppers here that'll spit out your items, along with these 2 hoppers that'll refill the droppers with items. Now, in order to refill these hoppers, you could have a hopper line going from a storage system, or you could have something as simple as a double chest above this. Doesn't really matter. The last thing to do is, of course, cover up the redstone. You can just cover up the Sculk sensor like this, and you can put blocks over here for the wall, but you can't have any solid blocks in front of the droppers. What you can do to hide the droppers, though, is like what I've done over here with a stair and trap door, or you could do something like a spruce door. Just place it in, and a block above, and then you have to power this spruce door somehow, because of course this observer clock will power it. So what you can do is go from behind, place a redstone block, and then just shut the spruce door, and you won't have any problems. I didn't fill the droppers up, so no items will be coming out, but as you can see, the spruce door is still firmly there, but you could also power it from this side here to keep it closed, and that'll work too. It's important to note you can't power it from above, because then that'll QC power this dropper here. And you can't power it from this side, because you'll power the hopper, unless you move the hoppers to the back, in which case you can work around this. This last step is just basically up to you how you want to hide the droppers. So, what is this thing actually useful for? Well, you can use it to get 64 food, or, of course, 64 fireworks, or you could have some custom block that you like redstone dust, or maybe glowstone for a respawn anchor. Really anything you can imagine this will be useful for. You could even modify it to make it so that it only shoots out 16 items for an ender pearl dropper. But, with all that said, let me just fly over here to my next contraption. And that next contraption is an elytra door. This elytra door will always open for you, no matter how fast you're flying with rockets, as long as you get within 7 blocks of a Sculk sensor. Obviously, things like tridents with Riptide 3 can make you go too fast. So, how does this elytra door work? Well, the moment the Sculk sensor activates, all the rest of the redstone is absolutely instant. There's no wasted time on things like Sculk frequency filter or even repeaters. As a matter of fact, the only repeaters and inverters I use are all instant. Like this instant repeater here, this instant inverter here, this instant inverter here, and another instant inverter there. That's not to say, though, that this elytra door is completely without delay. The Sculk sensors themselves cause delay. That's why this Sculk sensor is 14 blocks away from the door, and these two are both 15 blocks away from it. Because you see, when a Sculk sensor first detects a frequency up to 8 blocks away, there's a 0.05 second delay per block away that frequency is, with a max of it being 0.4 seconds because the farthest away a Sculk sensor can detect a frequency is 8 blocks in a spherical radius. So, that means this door will open in 0.05 seconds after first detecting your elytra, or up to 0.4 seconds after detecting your elytra. So it's not exactly instant, but the distance away these Sculk sensors are from the door will provide enough time for it to open before you crash into it. And if you want to see this delay for yourselves, I'm not sure if you can catch that, but there is definitely delay there. The moment one of these Sculk sensors activate, the door opens, and it's the same for all three. One important thing to note, though, is that this door can only work like this if the door is only 2 blocks wide. So let's look at the redstone itself for the door. As you can see, the actual door part is pretty simple, with these sticky pistons extended by this redstone dust that originates from this redstone block here, and it's the same for both sides. Now, the reason we have a sticky piston here with this redstone block is the moment it extends, the redstone block is treated as no longer being there, which makes it instant. And that same principle is basically used for the rest of these instant wire setups I have. So, let me just now explain how the other instant inverters and the instant repeater work. This instant inverter over here has a similar concept to this one over here. When this sticky piston is retracting, this block is treated as no longer being here, so this powered redstone dust connects to this redstone line and instantly powers it. This instant inverter here is exactly the same over here, just oriented different, so when the sticky piston is powered, this redstone block is pushed down, and immediately it's treated as no longer being there, so this redstone line immediately depowered. Also, interesting thing to note is that Sculk sensors QC power sticky pistons and they update them. So there's no problem when you QC power a sticky piston with a Sculk sensor. This instant inverter here, same thing as over there, just with a depowered piston. Once the piston is powered, this block is treated as no longer being here, so this powered redstone dust connects to this redstone line and instantly powers it. Now we get to the instant repeater where things get interesting. Once this redstone line is powered, that powers this block, which causes the sticky piston to push the redstone block on top, but that also causes the sticky piston below to retract, causing the sticky piston on top to zero tickets block, instantly powering the next redstone dust line. In the last instant inverters like the others, whereas when the sticky piston pushes its block, the powered redstone dust connects to the line, instantly powering it. The last thing to know about this elytra door is that you need to decide where the Sculk sensors go. They don't need to be in this 3 pattern, you could have them all on the floor, or off to one side, you could have one on the ceiling, one on each side, and one on the floor. Doesn't matter, you just need to work out how the instant inverters and instant repeaters will work to get this door to open, based upon your needs for the build. The most important thing to keep in mind though is that the Sculk sensors have to be able to pick up your Elytra in their 8 block radius. And now for my last design, the self-extending and retracting bridge. As you just saw, each block of the bridge is pushed up 2 blocks from under this pool of water. The water actually becomes solid water again, because as you can see here, I have these waterlogged stairs that refill the entire pool of water after the bridge is activated and deactivated. And the water seamlessly fills in. This could also work with lava instead, however, in this area here, there'd be flowing lava instead of source blocks. For this bridge, in terms of redstone, there isn't too much to talk about, however, it is some fairly complicated stuff. We'll start here with a Sculk sensor, which is waterlogged, and I also use wool to block out some of its detection radius. So, when you walk over here, Sculk sensor detects it and activates the whole bridge. Next up, this redstone dust here powers these repeaters on 3 ticks of delay, which each activate a monostable circuit, power rails, and activate this observer chain. And in each observer chain, there's an observer detecting those observers, which in turn powers either a powered rail or an activator rail, and they alternate to stop them from powering each other. This observer here then detects it, which activates this double piston extender. As you can see, it's a standard design, repeater and 4 ticks, observer, solid block, and then we have 2 sticky pistons here, with the blocks on top. There's nothing too complex about this bit. Every slice is the same as the last, except for the activator rails and powered rails alternate, and at the other end, we have the exact same thing. However, this time, the observers are all facing this direction. We have another row of observers which power a block, so that they power the corresponding powered rail or activator rail, which makes this bridge able to activate in both directions. Now we get a tad bit more complex, because if both Sculk sensors are activated at the same time, this bridge would ordinarily break. However, I have a mechanism to stop that here. There's a repeater on 1 tick, which activates this comparative decay clock, and this repeater here, which goes into this redstone dust line, and goes all the way into this instant repeater here, which carries the signal all the way to the end, to another instant repeater, which powers these 2 sticky pistons, which prevents the monostable circuits from activating. And it's the same on both sides. Again, we have the same comparator decay clock, repeater, instant repeater, and these 2 sticky pistons push out the blocks for the monostable circuit. This basically prevents the bridge from breaking if both Sculk sensors are activated at the same time or around the same time. I hope I did a good job at explaining that, because basically that's all there is to this bridge. It's simple, but also not at the same time. And here's just one more showcase of the bridge working, and yes, it does work if you sprint, or if you jump sprint. You would need to adjust some timings though if you use something like speed 2, or you replace the blocks with soul sand or soul soil and use soul speed. That's all I've got for Sculk sensors in this video. I will of course be revisiting them in the future, but for now, thank you all so much for watching. As always, if you have any questions, comments, or concerns, please feel free to leave them in the comment section below. And if you enjoyed this video, make sure checking out some of my previous videos, including my one about axolotls and my one about the helmet breaker trap. Also, make sure to come back next time for my next video. Once again, thank you all so much for watching, and goodbye.